Here we go.
This is all fake laughing.
Fake laugh. Let's do it. Wait a minute. It's the outro, not the intro.
Oh, sorry.
Here we go. I'm recording, so let's do the lesson. All right, here we go. With this is looking to see if our functions, there's three options, odd, even, or neither. Okay? Odd, even, or neither. Any function, so let's be off the phones as well, off the phones. Any function we can assess to be odd, either, or neither. Okay. The main thing that happens is we are always going to be plugging in negative x into the function and to see what we end up with. We put in a negative x instead of x. We work it out, see what we end up with. Okay. Now, if I plug in negative x and I end up with the same original function, I plug in a negative, but it all works out with the, looking over here, we can see situations where it end up with the same thing, right? So if I end up with the exact same function that I started with, then it's an even function. If when I plug in a negative x into my original equation, I end up with every single sign of every term is the opposite, then we'll call it odd. And if neither of those are fulfilled, we'll call it neither. Okay. That is more abstract, so are these graphs. Once I get into the examples, you'll see that it's just like the warm-up as far as how hard it is. Okay. Now these even functions, they're also reflected across the y-axis. So you can see here, here's my y-axis. It's exactly the opposite on the other side, right? You take this, you flip it. It has the same shape on the other side of the y-axis. So that's how we know if we look at a graph, we can see if it's odd or even. This one, the same thing, right? It's exactly the same on left and right. Up here, this one is actually rotating 100 degrees, 180 degrees about the origin. It's like a propeller. Okay? It's like a propeller because this part of the function here, we could see that if we rotate it 180 degrees, then it's on this side of the graph. You see how this is rotating 180 degrees? Let's see. So halfway around the circle, right? From here, the other direction. You see how that's a rotation of 180? I want you to try to do this. I just thought of doing this. Let's try it. How about if our function was some weird piecewise function where it was like this? Come on. If it was like that, I want you to try to rotate that 180 degrees just on the side and the margin. This is a really weird function. It's possible. It would just be a piecewise function, like between here and here is this, between here and here is this, and so on. So I just want you to rotate this 180 degrees, more so out of like spatial reasoning practice. I want you to try it. So we're looking at rotating this 180 degrees. So what quadrant is it going to end up in? Here we have 1, 2, 3, and 4. It's going to end up in quadrant 3, right? So who feels pretty confident? Pretty confident they can do it? Yeah? Okay. No? Who else is confident? Yeah? Super confident? That's a hand shaking. Are you more than this?
Yeah.
Okay, here's my laser, right? Laser. I want you to do the laser where I should draw. So start right here, right? Start right here. And what should I do? What should I do?
It's 180 degrees, right?
Yeah.
So that should go.
Yep.
Yeah.
So this right here has to be rotated like that.
Yes.
Then what?
Then this right there.
Yeah.
Will be right there.
It's pointed up.
Yeah.
Yeah.
And then that line there is going to be
like that?
Yep.
Boom. You're the first one to have a laser pointer in the presentation.
It felt awesome.
I thought it probably would be pretty cool to do this. We did it.
You should try it.
Sure. Next time?
Yeah.
Okay. All right, so we can recognize graphs. Bring it back. We can recognize graphs that are odd because it's rotated like that. This is all conceptual stuff. There may be something on the quiz that has you recognize odd or even. But now we're going to actually work out algebraically, and you'll like the algebra. You'll like the algebra from this. First step. Everybody rewrite this f of x. Just rewrite it because we're going to look at it carefully. There's our f of x. Now, the next step, and this is going to help everybody out quite a bit. You may not like it if you're somebody that can go quick and kind of skip steps, but I want you to try this. First thing is to put parentheses around where the x was. Okay, you have to put these parentheses. Without the parentheses, I can think of a couple places where you'll make mistakes, and we'll have an example up here where we can see that. Next step, let's go ahead and instead of plugging in x, see I just erased this right here, we're going to plug in negative. We're going to plug in negative x, right? Okay. And that's a step every single time. You set it up with parentheses, really carefully with parentheses. We plug in negative x instead of x, and then I'm going to see what happens. It's like an experiment. We're going to see what happens. If I have negative x, and I raise it to the 4th power, think back to the warm-up, what's going to happen when I raise negative x? Let's see what happens. Negative x, negative x, negative x, right? Because these two, x squared. Those two, x squared, both positive. All together, x to the 4th. Right? You see it? For sure? So we get 3x to the 4th. Now, this is where I ended up. This is where I started. Compare the answers to both of those. What do you see? They're the same, right? They haven't changed. They're equal to each other. So essentially, if I wanted to really write it out, from here I know you can just choose if it's odd, even, or neither. What do you think?
Well, I think it's even, but
good.
I have a question.
Okay.
So when it's like one of those problems like that, it's like 3 to the 4th, can you just like skip all the steps and just go straight to the end? It's like an even, you know it's going to be an even, or...
I see, because of the 4th power. That won't always happen when we have a function that has like to the 4th power, 3rd power, 2nd power. So if it was really obvious and basic like this, I wouldn't mind you making that assertion. But for the classwork, I want you to work it all out without shortcuts. Just for today. If you did that idea on a test, I would need you to write that. One term, even degree, it's got to be even.
Wait, so like say for like the first one was a negative and then the second one was a positive, would that be like neither?
That would actually be odd. So it's odd if every term has the exact opposite sign. That would be an odd function. An even function is when I plug in the negative, I end up with an answer that is exactly the same as my original function. We're going to get to odds over here. Why don't we wait to that one? But we can see here, this is the same as this, right? Essentially, it's saying that f of x is equal to f of negative x. So we know it's even. Even. Okay? It's just the first part. Just the first part, too. All right, let's look over here. Example 2. Example 2. It's pretty good. All right, everybody, rewrite g of x. G of x is equal to 2x squared minus x. And then I'm going to go ahead and put in my parentheses. This one's real important to put those parentheses in there. Okay. Now, what am I going to plug in for x? Every time, every time, every time. Okay. From there, I want you to work it out. See what you get as your final. And then we're going to compare it to our original. Two what? X squared, because negative x times a negative x, that's x squared. What happens here? Plus x. Now, is this the exact same thing as our original equation? No. We would check that it's odd by looking at each term and saying, well, is this the opposite term as this? No, it's the same term. Is this the opposite term of this? Yeah, that's the opposite sign. But both of them don't do that, right? It's neither. Neither and neither. The answer is neither for that, because that's what we're being asked. Got it? All right, let's see about this odd. This one, well, you can tell. Test maker's hat. We had even, we had neither. Probably odd. Let's see how it works out so we at least know. Okay. Rewrite the function. Now go in, put in your parentheses. Oh, and we want to now input that negative x into each one. Negative x, and then work it out. Work it out. We know this is a odd. Block the sun. You see it?
Yep.
I'll just stay here.
Not helping.
Not helping?
Oh, there you go.
Yeah.
Stay there.
Right there?
Yeah.
It's fine.
Brian, I need to be this side more.
I'm fine.
She's got the hard angle there. It's hard. All right, what is this going to be? Nice quotation marks. What's it going to be? Good. Negative x cubed. How about this negative 2 times the negative x? Positive 2x. Now let's look. This is what h of negative x is. It's right here. Is that the exact same thing as where we started? No. What can we see? From this term, we have positive x to the third. What's it down here? Negative x to the third. Negative 2x, what's it here? Positive 2x. Okay? So because every term is the exact opposite side, what do we call this? You see, it's odd because it's exact opposite. Right? You could have also seen this. One sec. You could have also seen this as I could factor out a negative, and this is x to the third minus 2x. That's where we started, except the whole thing is negative. It's the opposite. But I find it a little easier to just kind of look at, is each term the opposite side? Is that easier to check that way? Okay. We'll keep it like that. If you can factor out the negative and you like that, do it. It's basically just saying, like, it's exact opposite. It's the doppelganger of our original here to here. Opposite. It's odd. Thumbs up, sideways, down. What do you think? All right. Yeah. I gave you about 25 plus minutes to do classwork. This is where you get all the classwork done. Like literally, this is, a lot of people are studying, and don't ruin it for them because I want to give you this time to use. Yeah. And then what are we going to do as our outro, man? What do we do for our outro? You want to do some laugh therapy?
Yeah, like, this is like fake laughing.
We got this laugh thing going. It's on Emoto. It's not a workbook. We don't have critical mass. Yeah. All right. Laugh therapy tomorrow.